Hello, everyone. Welcome to this presentation. My name is Siavai Sadeghi, and today I'm going to give you some information about Hyperloop propulsion power system and how we are going to work with ETAP on designing the power distribution system for our propulsion system at HyperloopTT. A bit about myself. I'm the propulsion and levitation technical lead at Hyperloop Transportation Technology. Previously, I was working for General Motors Advanced Technology Center, Capstone Turbine, Resmed Motor Technologies, and Honeywell Aerospace. And I have about 15 years of experience in the electric motor design and control area, power electronics. I have about 25 technical journal papers in this area and 6 US patent published and pending with 4 trade secrets. I'm the senior member of IEEE from 2012, and I received the 2014 Southern California Outstanding Engineer Award. About Hyperloop. I joined Hyperloop in 2018, almost 3 years, where we started at exciting technologies, designing linear motors, propulsion system, and passive levitations based on the permanent magnets to lift a 30 tons capsule almost, and moving at the speed of 1200 km per hour. Very exciting and challenging projects. Today, I'm going to give you some information about the propulsion power system. I know that it's a complex design, but in 20 minutes, I can just give you a general information about that. About the current transportations, in my opinion, the current transportation industry is broken. Although the industries are pushing towards the more electric EV system, basically electric vehicles and electric aircraft, eVTOL for transportation, but still there are 3 main issues with the current transportation system. One is public subsidies. You know that, for example, in New York, based on the study that we have done, New York subway subsidized 75 cents per passengers in 2015. It's almost about $1.3 billion. It's a huge money. Second issue with the current transportation is time loss and wasting time in congestions. We have some numbers here for some major cities like Boston, London, Mexico City, Istanbul, and Moscow. And you can see we are wasting more than 150 hours almost in each city with a speed close to 18 kilometers per hour. It's not efficient at all. The third and main reason for the current transportation is the emission and pollution that they are producing. As you know, about 23% of the global carbon monoxide emissions coming from the transportation. All the diesel machines or the gasoline machines, pollutions, and right now the concern with the global warming is basically pushing the industry towards the more electric transportation. We are offering Hyperloop system, and why? Because Hyperloop is high speed, is efficient, is safe, and there is no friction, and is profitable as well. High speed. We are claiming that the Hyperloop can reach to 1200 km per hour, and the reason is The main roadblocks for the current transportation that cannot reach to this speed is the aerodynamic drags and also the frictions because of the tires and wheels. What we are doing at Hyperloop is we are removing the wheels and tires, and we are using magnetic levitation system. And we are using low pressure tubes, and we put the capsule inside the low pressure tube to reduce the aerodynamic drag almost to zero. In this case, we can reach to 1200 km per hour. Profitable system. We had our Great Lakes Hyperloop feasibility study released last year. And in that report, we said that the HyperloopTT system, due to its inherent efficiencies, is a high-speed transportation system that truly makes economic sense. And based on our study, we came up with the ratio of 2.24 positive benefit to cost ratio with zero operating subsidies. It's a very profitable system for the transportation. Sustainable mobility, we are saying that at Hyperloop, we can produce more energy than it consumes. And yes, that's true. We are integrating some renewable resources and to our system. One of the main renewable sources is solar panels. We are going to put the solar panels on top of the Hyperloop tubes, and we are going to put it on top of the Hyperloop tubes, and we get the energy from the solar, and we transmit the energy to the utility. The energy that we are going to get from the solar, based on our calculation, is almost the same as the energy that we are using for the propulsion system. And basically, it comes to the net zero energy consumption. Among the lowest carbon emission transport options, we are producing less than 20 grams of carbon monoxide, which is pretty good compared to the other transportation industries. HyperloopTT system, how it works. Hyperloop includes some main components. Its capsule is tubes and propulsion and levitation system. For propulsion system, we are using linear motors. Again, enables emission-free transport. For the levitation, we are using passive levitation system with permanent magnet. So it reduces the friction and which increases the efficiencies. Fully enclosed environment protects from weather and traffic crossing. And also we have solar panels and other alternative energies embedded in our systems. Right now, we have our R&D center located at Toulouse, France, where we are doing our testing and certification. As you may saw, we built a 320 meter tube, full scale tube at Toulouse, France, and we installed our vacuum pumps, and we started doing the vacuum testing. We achieved close to 100 Pascal pressure inside the tube with minimum leakage, which was a big achievement for us. And now we are working on testing the propulsion components. We built 2 full-scale linear motors, and we did some control testing. Now we are working on a big test bench that we are going to run some thermal cycling on our linear motors. Based on the data, we are going to do some optimization probably. Also, we are working with TÜV on developing the certification guidelines for Hyperloop transportation system. We also have a commercial prototype in Abu Dhabi. This is the project that we are going to work with ETAP on the power system design part. The track is located close to Expo Airport. The concept design completed. It's a 5-kilometer passengers Hyperloop. And we have also another project, cargo prototype in Port of Hamburg, Germany. Energy distribution. The energy sources in the Hyperloops, basically we can categorize them in this picture and in mainly 3 parts. One part is the renewable part, which is the solar energy generations. We send the energy to the utilities and battery system. The other source of power is the grid. We use the grid for powering the linear motors and vacuum pumps. Another source of energy is the energy recovery from the propulsion system during the braking and decelerations that we are going to store in the battery, or we send it to the grid. We have also onboard energy, which basically used for HVAC inside the capsules, some power electronics, smart power electronics, and lighting system. If I want to put the detail of the propulsion power system, we have the grid. We have high voltage AC transformer. We have AC bus bars, low voltage transformers to send the energy basically to the vacuum pumps and control room. We have low voltage transformers and rectifiers to rectify the AC system to DC and use that DC energy for energizing the inverters for the propulsion system, also for connecting the battery units and resistive loads and auxiliary diesel system to the propulsion system. Beside that, we have solar panels and power distribution for the solar panels along with the AC to DC converters and DC to DC converters for utility feed and also for a stationary battery system. The 5-kilometer projects that we are going to work with ETAP to design and develop and executing the manufacturing part is the 5-kilometer and profile is going to be the first commercial prototype. We are going to have 2 types of capsule in this profile. One is 25 tons. The maximum speed for that is 250 kilometers per hour. This is the capsule that we are going to have passengers on board. We cannot go over 250 kilometers due to the track limit to 5 kilometers and acceleration limit that we need for the passengers' comfort. But we have another 10 tons capsule, no passengers, and with high acceleration when we can achieve 620 kilometers per hour speed in this 5-kilometer profile located in Abu Dhabi. Why ETAP? So as I explained, we have a very complex power system distributions. We need expert to help us to design and develop that power system. And based on research, we get to the ETAP. ETAP is an industry leader for digital twins also, and they're doing design, operation, and automation. They have a very powerful software and especially for the traction systems. They just developed the eTrack software, especially for the railway system that could help us also. Another thing is the co-simulation feature of their software. as we have most of our simulation in MATLAB Simulink, we can do some co-simulation with ETAP to accelerate the development. They have expert in different area, railway system, substation designs, power quality, and power factor design system. Collaboration with ETAP. ETAP is going to design and basically operate a Hyperloop autonomous system, design transmission lines. They are going to help us with the design of high voltage substation to take the power from the transmission line and transfer to the motor side using variable frequency drive. Help us with designing and defining the main and high voltage transformers, rectifiers, DC bus, inverters, converters, and isolated transformers. Designing, defining the renewable energy sources, designing the power factor correction for our high inductive load and to maximize the efficiency. ETAP and HyperloopTT design and operations lifecycle. The iterative design changes will be at any stage are incorporated into the digital twins, and the ETAP digital twins of Hyperloop includes interconnection planning, help us with conceptual power system technology, topology, sizing and dimensioning, vendor selection, bill of material, monitoring, operate and validation, solar energy collections, and grounding and cable thermal analysis, EMI and EMC, basically covering most of the part. ETAP study for conceptual design. We already started designing. We started with, from the power distribution part between the inverters and the linear motors. We have segmentation for the linear motors along the track. Different segmentation, different lenses from 100 meter to 300 meter, which basically creates a different active and reactive power needs. So ETAP started modeling of those loads for us. Detailed simulation in ETAP time domain and doing a load flow is another work that ETAP is in the process. They are helping us with the trade-off study on AC distribution versus DC distribution along the track for powering the propulsion system. On the case studies that they are doing is, we have a 5 kilometer track, we have the linear motor inside, and we need active power and reactive power. And based on the mission profile, we go to high speed and low speed. We have different requirements for the active and reactive power. So the problem is we don't know if we need to put one set of inverter in the beginning of the track and use that inverter to energize the entire track with multiple switch boxes, which we put along the track, let's say every 250 meter, and we have a penetrations and we just feed the linear motors, or we put 2 inverters, one in the beginning, one at the end, and energizing the linear motors, or we do DC distributions along the 5 kilometer and we put one small cell of the inverters and each penetration every 250 meters. So this is a trade-off site that right now ETAP is helping us with that to find the best spot and best configuration from the efficiency standpoint, cost standpoint, and manufacturing standpoint. 2 main challenges that we have for the 5 kilometer concept design is high inductive load. So we are putting together the modules of linear motors, which creates a high inductance load and high inductive load. And since we are at the maximum acceleration and maximum deceleration, because we have a short track and we want to get to the maximum speed and decelerate, we have maximum current most of the time on the motors. So maximum current, high inductance, which bump up the voltage a lot. So we would like to know if we need to put some step down, step up transformers, if we need to put power factor correction at the motor side, at the DC bus side. These are the things and challenges that we are facing with right now. ETAP, a study for conceptual design, a study for selection of grid intake supply voltage, is another task for ETAP, basically to evaluate surge impedance loading of transmission line, is a selection of intake cables and also conductor sizing, cable sizing, considering the thermal and short circuit capacity, load flow analysis for various voltage options to arrive at the required intake supply requirement based on the acceptable loading and voltage drop criteria. So you can see it's a very big project. It's a very challenging project and also exciting. It's a new technology. We are facing with new sets of requirements for power and active and reactive powers. All these, low power factor, designing the power factor corrections. These are all the exciting work that we are going to work with ETAP to design and develop those. I try to cover, the general information about Hyperloop propulsion system, but for sure, 20 minutes is not enough for this technology. And you can always reach me and ask your question. If you have any question about Hyperloop, we would be happy at HyperloopTT to help you to understand more about Hyperloop technology and high-speed trains. Thank you, and I hope you enjoyed these presentations and have a good rest of the day.